So we left off right before lunch, kind of talked about these two ideas right here. So I want to piggyback up that, and then also discuss the third and other scenario that we have. All right. So real quickly again, parallel lines. If we know two lines are parallel, picture-wise, we know that those are two lines that do not intersect. This is the notation to show that they are parallel. If I tell you that two lines are parallel, what do we know about their equations? Number one, they have to have the same slope. And number two, they have to have a different y-intercept. Okay, all of that stuff needs to kind of go hand in hand. Now, second type of line, perpendicular lines. Remember that perpendicular lines are two lines that intersect to form a right angle. Okay, that's what the picture of this looks like right here. What do we know about their equations? We only know one thing. And the one thing that we know is their slopes are opposite reciprocals. Now, we talked about this last year. We probably don't quite recall that. So I need to do a quick recap. What do I mean by opposite reciprocals? Okay, part of it is changing a positive to a negative or a negative to a positive. What part does that tie in with? Hold on there, though. Changing a negative to a positive and a positive to a negative is talking about doing the what with that. That's the what. What do we call that? It's on the board. No, that's not a reciprocal. That's a what? That's an opposite. Okay? Carly, what else were you saying, though? Flipping the numerator and denominator. What's that called? That's the reciprocal part. So if we're talking about slopes being opposite reciprocals, and I said that this line in particular had a slope that was equal to 3/4, what would the other line's slope have to be? Not just 4/3, a negative 4/3. Okay? It's got to be the opposite. So if this one's positive, this one must be negative. If I told you that an original line had a slope of negative 5/2, what would its perpendicular line have to have a slope of? 2/5. Okay? If I told you that an original line had a slope of 3, what would its opposite reciprocal have to be? -1/3. Because remember, you can't just take this and make it negative. You have to think of that as a fraction and then flip it. Okay? So, those are the two new scenarios. But again, here's the thing. If we don't talk about the third scenario, people don't even realize that it exists. And here's what I'm going to tell you. Happens sometimes, not super common. Happens sometimes, not super common. The third scenario is going to happen more than anything else. Okay? So, what do we have if our lines are not parallel and they are not perpendicular to one another? Pretty much we're going to summarize it and say this. They are intersecting lines. Now, there's nothing unique about these other than the fact that they intersect. What's a picture of this possibly look like? Here's one. Here's another. Those two lines intersect. So here's what you know. They're not parallel. Because parallel lines can't intersect. But while these intersect, they don't intersect at a right angle, so they're also not perpendicular. This is probably the more common scenario than any of the others. But again, because it's not actually talked about in the textbook, a lot of people are like, oh, that just doesn't even happen. They feel like it's got to be one or the other. There's three cases here. Okay? Now, there's no markings to show on here because there's no parallel lines, there's no right angles. Okay? Here's my question. And this is something you're going to have to know as we move into unit number 6. Can anyone tell me anything about their equations? How are you going to force two lines to intersect one another? How are you forcing two lines to intersect with one another? We know how to make them parallel, we know how to make them perpendicular. My question is how do we make them just intersecting? Carly, thoughts?
Keeping the slope the same and the y-intercept the same?
Nope, because if the slope's the same and the y-intercept's the same, they're going to be the same line. I want to look something like this.
Same y-intercept.
Do they have to have the same y-intercept? No. But the other part is true. Here's what you know. Their slopes are different. What do I mean by that? First of all, these two lines as I sketch them, I hope we'd all agree that these all have to have positive slopes, right? This line has a slope of 5, this line's got a slope of 5/2. There you go. They're going to intersect one another. The only way they won't is if they have the same slope. Okay? So, when we get to solving systems of equations, which we're going to begin in probably about 6 days, these are things that we're going to come back and revisit. Okay, but for our parallel and perpendicular, I wanted to make sure that we talk about these as well so we understand, again, there's 3 things to consider. Okay? All right. Now, let's go ahead and continue to move on to the rest of our notes. I want to get through the next 2 examples here. Okay, where we are asking you to write the equations of lines. And again, we're going to do in each of these, we're going to do them 2 different ways. Oh, let's see. ImageMate projector. There we go. Nope, that's not what needs to happen there. Close. Close. Open. Open. All right, so down to example 1A. And again, we're going to do each of these in both forms, and you're going to pick one, and you're going to get comfortable with that. If you want to work with both, you are free to work with both. Write an equation of a line that passes through 2, 6 and is parallel to the line y equals negative 1x plus 2. Okay, what 2 things do we always need to write the equation of a line? Slope and a point. Okay, guaranteed. That's the 2 things you have to know. Now, they might not tell you those 2 things, but you should be able to find them from what they tell you. Okay? So, first of all, we want to make these parallel. How do you make lines parallel to one another? We just got done talking about this. They must have the same slope and a different y-intercept. Now, I can't force my y-intercept to always be different, but I can do this. I know that this line right here has a slope of what? Of what?
-1.
Caleb, how do you know that?
Because the negative's right on the x or y and over.
What form is that equation in though?
Y.
Slope-intercept form. So in slope-intercept form, we look at the value that's in front of the variable. That tells us what our slope is. So this line has a slope of -1, which means in turn that our new line needs to have a slope of what? We want it to be parallel, so what's our new line have to have a slope of? -1. I ask that because that's not always going to be the same, is it? Sometimes we're going to want to force it to be something different. So this is the slope I need to use, and we need to use the point of 2, 6. So ultimately, here's what I've got. Write the equation that fits that scenario. Again, 2 ways to do it. One of them is going to be much faster than the other if I choose to use point slope form. Okay? This is going to be y minus what? 6 equals -1 times the quantity of x minus 2. And if I want to do point slope form and only point slope form, there's my answer. Okay, if I want to do slope-intercept form, you would begin by taking your slope, which is -1, and then you would need to use your ordered pair to find your y-intercept. This is what we did prior to Christmas break. So you plug 6 in for y, you plug 2 in for x, and then we'd solve for b. Add 2 to both sides, b would be equal to 8. So we'd have y equals -1x plus 8 as an answer. Again, when it comes to your assessment next week, I don't care what form you write it in. I should say when you come to your assessments, you're going to have one on Wednesday, you're going to have one on Friday next week. Okay? All right. Pretty straightforward though. Again, really the only thing that we needed to know here is this new idea of parallel. And for lines to be parallel, their slopes must be the same. Okay? So now let's take a look at example 1b. Write the equation of a line that passes through the point of -3, -5, and it is parallel to the equation 5x plus 3y equals 30. Again, we want to make them parallel, so what do we know about their slopes? They're going to have to be the same. Do you know what the slope of that line is? Why is it 5, Caleb? Okay, it is the value in front of the x, but that only works if it's in slope-intercept form. Is this in slope-intercept form? Nope. So do we know what our slope is? No. We're actually going to have to do a little work here. If I want to know what the slope of this line is, I would solve this for y. I would make it into y equals mx plus b form. So, Riley, what are we going to do first to solve that equation for y? We're going to subtract 5x from here, subtract 5x from here, so now we have 3y is equal to a -5x plus 30. Okay, Canuck, where do we go from there? Divide by 3. When we divide by 3, recall that we divide every piece of this by 3. So 3y divided by 3 becomes y, -5 over 3. I try to reduce it if I can. In this case, it can't be. So -5/3 x, and then 30 divided by 3 is going to give me 10. So this line right here, Carly, has a slope of what? You don't need your calculator out. We've just converted it to y equals mx plus b. -5 over 3. Caleb, what does that mean our slope needs to be?
-5.
-5 over 3. And the point is going to still be that ordered pair of -3, -5. This is the information I need. Now here's something I want to point out because sometimes this will come up. Mr. Tompkins, what should we do with the y-intercept in that first equation? Nothing. You don't care about it. If you're looking for parallel lines, all that you really need from that first equation is the slope. So, if this is my information and I want to write that equation, I can do it again in point slope form. Y minus -5 is actually going to become y plus 5 equals, it's going to be -5/3 times the quantity of x. If we minus the -3 again, that's going to become a +3. So there's my final equation in point slope form. Okay, again, if I really want to do it in slope intercepts, I'd start here, plug in your points and solve for b. So plug in -5 for y, plug in a -3 for x. This is going to become -5 is equal to 5 plus b. If I subtracted a 5 from both sides, b turns out to be -10. So our equation would end up being y equals -5/3 x minus 10. Okay, I think you guys probably know which one I think is easier. Okay? But if you want to do that extra work because it's something you're more comfortable with, you can continue to do that. All right. Now let's go to the go to example 2a. Write the equation of the line that passes through negative 2 comma 1 and is perpendicular to the line y minus 5 is equal to negative 1/3 times the quantity of x plus 4. Caleb, do we know what the slope of the given line is?
No, yes,
Well, which one? It's one of those two.
yes.
Okay, why?
Why? Because of one.
What form is that equation in?
Point.
It's in point slope form, okay? So if it's in a form that we already know, then that's great. Caleb, what is the slope of that line?
Negative 1 over 3.
Negative 1/3. Now, this is where you need to be careful. We're talking about perpendicular. Adriana, what's that mean the slope of our line needs to be? 3/1, which is just 3. So we're not using the same slope, we're using the opposite reciprocal slopes. Okay, now our point was given, that is negative 2 comma 1. This is the information that I'm using to write my line. Okay, do I need the slope of that other line? No. Do I need the y-intercept to the point of that other line? No. Once I got what I need, this is now my new problem. Write this equation. Okay, in point slope form, that would say y minus 1 equals 3 times the quantity of x minus negative 2 is actually going to become an x plus 2 there. All right, slope intercept form, y equals 3x plus b. We would plug 1 in for y. We plug negative 2 in for x and solve for b. Add 6 and add 6. So b is 7. Y equals 3x plus 7 would be my slope intercept form. All right, does that make sense for that one there? Okay, so for our last example today, we're going to get to example 2b here. Write an equation of a line that passes through the point 6 comma 0 and is perpendicular to the line of 6x minus 3y equals 27. Evan, do we know the slope of the given line?
No,
Why not?
because it's not in point slope form.
Or it's not in slope intercept. Those are the two that we can use, isn't it? So our job is to get it in the slope intercept form, okay? So Evan, how are we going to do that here?
Subtract 6x from both sides.
All right, so that gives us negative 3y is equal to negative 6x plus 27. Okay, Miles, what are we doing from there?
Dividing both sides by negative 3.
Divide everything by negative 3 and reduce. This now becomes y equals 2x minus 9. Okay, all we did is take an equation that's in standard form, that's actually what we call this, and converted it to slope intercept form. Okay? Lily, what's the slope of that line? 2. Mulnick, what's that mean our slope needs to be? Close. Remember, you also got to flip it. So what's on the bottom of that 2 right now? A 1. So when I flip it, actually, my slope I'm going to need to use is what? Negative 1/2. And our point, that was one of the givens, was 6 comma 0. This is what I now need to use to write my equation. All right, now there is a 0 in this problem, so make sure that if we're writing it in point slope form that we have simplified that. So y minus 0 is just y equals negative 1/2 times the quantity of x minus 6. Okay? Slope intercept form, y equals negative 1/2 x plus b. Plug 0 in for y. Plug 6 in for x. 0 equals negative 3 plus b. And if I added 3 to both sides, then b is 3. So we'd end up with the equation y equals negative 1/2 x plus 3 as an alternate version for that problem. All right. So questions that you have for me on this? Again, not only is this a standard we're looking at right now, but this parallel and perpendicular, I cannot emphasize it enough. It's going to come back up. Okay, right away when we get into unit number 6, we're going to need to know what we're doing with these particular ideas. Okay, so give me just a second here so I can jot this down and put it up on the board. 261 numbers 1 through 11. Okay. So your assignment for the weekend is going to be page 261. Okay, numbers 1 through 11 odd, followed by 19 through 25 odd. Okay, make sure that you read the directions on what it's asking for. You're not just trying to guess by looking at the problem. And you are, if they ask for it in a specific form, then you need to make sure that it's given in a specific form. Okay? If it doesn't specify, do whatever you like.